Yeah, there we go. Okay. Now the video is frozen because I must have unplugged the webcam instead of the audio. So let's get rid of that. Oops. As always, something has to mess up. Okay, I think we're good. I think we're ready. Let's begin. So, okay. Can you all hear me? I hope so. Let me check. Okay, there we go. Yes. I checked. So, let's begin. So, what an absolute mess. Yeah, so as it turns out, when I was coming home on Monday, right? Monday, going home, I got home. That was fine. And then I went out later to get food, but didn't, right? Because there was a flat tire. So yesterday I took my tires in, and turns out that they just completely forgot. They didn't do anything with them. They didn't fix them. They just let them sit. They didn't actually do anything. So I called them today. I was like, hey, why didn't you call me yesterday? Get this done so that I can come in and do my job. And they said, oh, wait, you left tires here? And I was like, yes, I did. So that happened. So totally forgot to fix them. I suspect you are some kind of, let's see, remove. No, I want to, what? How do I, move? Okay. All right. So totally forgot to fix things. So we will be back in person on Monday. This was just a huge disaster, bit of stupid that happened. So, okay, let's talk about functions again. So back to the course. What about functions? So, yeah, what about functions? So what is a function? Right, a function is a kind of sub-program in a way, right? It's a piece of code that can be called whenever we want and executed. Let me see if I can turn the webcam back on, just out of curiosity. I know that people like to see it works now. Okay. And executed, and then returns values back to the original calling location, right? So a function is called from a specific place somewhere else in your program, and then what happens is the function runs, and then at the end it returns its value, right? So so that's what happens. Okay, so what can functions do? So functions can return values, right? And so what kind of values can functions return? Let's see. What kind of things can functions return? They can return, basically they can return anything. They can return lists, int, float, bool, etc. They can also return, so if you don't have a return type, they return none, right? That special none type thing called none. Returning a value allows the result of a function to survive, right? You can set it to a variable, pass it into a new function, or print it out, whatever we want, right? If we don't set the value to a variable, the value is lost, even if it is returned. Okay, and then functions also have arguments and parameters. So functions have parameters, right? So for instance, let's just say check Pythagorean, O or N. So A, B, C, right? So what we're going to do is we're going to define a function here. So remember, to define a function, you type def and then check Pythagorean, A, B, and C. Those are the parameters, right? A, B, C are the parameters. And so basically, we're going to check to see if something is a Pythagorean triple. So remember, a Pythagorean triple is something such that, you know, a squared plus b squared equals c squared. And I'm using pseudocode kind of notation here. What I really mean is, we'll say, like, if a squared plus b squared equals c squared, then we'll return true, else we'll return false, right? So, you know, we can use a function a whole bunch of times. So for instance, let's say that we want to check to see a whole bunch of Pythagorean triples. Let's do the most, I don't know if this is smart or dumb. I don't know. Yeah, so we can call a function like this. We can say for y in range, say 100. And then we can say, I don't know, for z in range 100. I mean, this is not necessarily smart, but whatever. We can say if check Pythagorean x, y, z, then we can print out x, y, and z, right, as a Pythagorean triple. So, of course, who knows, right? Let's see what happens when we do this. I'm kind of curious now. It's going to print out a lot of things, I think, but it doesn't matter. Oh, Lord, that's probably too much. Let's say limit equals, say, 20. Let's just make this limit. Like that. And then let's do this. Okay. So we got a lot of zeros. Because zeros, oh yeah, zeros. So we always want to start at 1. We don't want to start at 0. Because, there we go. 0 doesn't make a triangle. Here's some good ones, right? 3, 4, 5, that's a Pythagorean triple. 5, for the Fibonacci sequence homework. On homework 4, don't use functions. So only use while loops, for loops, if statements, that kind of stuff. Basically, you can use functions on homework 5. So homework 5 is the functions homework. So where is, what is it? 5, 12, and 13. 5, 12, and 13. Yep. I guess 8, 15, and 17. That must be one. 8 squared, right? 8 times 8 plus 15 times 15 is equal to, 289. That is equal to, interesting. So we've calculated a bunch of Pythagorean triples, right? And the cool thing is all we had to do was we wrote this function that did the checking for us. And so you see that here, we didn't have to write the whole code. We just kind of said, if check Pythagorean, then it's a Pythagorean triple, and we can output it, right? So, okay, so that's a good example. So notice that x, y, and z here are called the arguments, because they are the literals that get stuffed into the function, right? And inside the function, x, y, and z get renamed to be a, b, and c, right? So inside the function, x, y, and z don't really exist. Outside the function, they're x, y, and z. Inside the function, they're called a, b, and c. So, okay. What else we got? So, what other kind of things can we do? I wrote a replace function, maybe. So let's write a replace function. Fibonacci. So let's write a replace string, right? So, and this is a good use of pass, for instance, because when you have a function that you haven't really written yet, or say an if statement that you haven't really written yet, like this, it's okay to put some passes in, just because it just prevents your code from having any errors or anything. So you know that if you click run, the code will still run. It doesn't have any errors. If you took the pass out, right, it's going to just say indentation error. So if you want to be able to run your code without actually writing everything, which you do a lot of the time, right? You don't want to have to write. If you had to write every last line of code before you could hit run once, then testing would be an absolute nightmare, which I assume sometimes it is. Okay, so there is a string replace function and all that, but we're going to rewrite it. So what we're going to do is we're going to take a string, and anytime we find a letter, we're going to replace with the replace with letter. So what we're going to do, so there's two ways that I'm going to do this. Here's the first way that I'm going to do. This is what I usually do in class. I'm going to say new string, right, equals empty string. And remember that new string here is a local variable. So remember that it has a lifespan, and it only lives as long as the function lives, right? So so new string won't survive the function, but we will return it. So what do I mean when I say it only lives as long as the function lives? What I mean is that the value, the string that's inside, gets returned, but the name, new string, goes away, right? Gets garbage collected. It depends on what you want to say about it. You could say garbage collected, you could say gets deleted, you could say whatever, but basically that's what happens to it. It leaves scope. The right hand, gets deleted, leaves scope, is destroyed, right? Those are all ways to describe what happens to the variable once you leave. So let us go through the letters. So this is going to be a for each loop this time. So I'm going to do for the character in a string. And then what I'm going to do is I'm going to say if the character is equal to the find letter, then we will do new string and then concatenate the replace with, right? So the reason why we want to concatenate the replace with is because if the character is equal to the find letter, then that's the one that we want to replace. We want to replace the find letter with the replace with, so that's what we're going to do. And so then, and we also have to remember that if we don't do that, we have to just concatenate back on new string, like the original character. And that's really it. So that's all we have to do for that function. And so let's replace funny. Let's replace ends with C's, right? And print it out. Just see what happens. Right? Should replace it and become fuzzy. And so the question is, does it do that? Yes, it does, right? What's another example of a word that we can do this with, right? Replace, where we replace a letter in a word and it becomes a new word. That's a hard question, right? I guess you could do something. I mean, I just thought of this one. It's not very creative. You could replace like that, right? Art, you could replace a T with a K, get arc, I guess. I mean, as I say, not exceptionally creative, but I guess it's technically an answer. Right, so, okay. And you see that it's replacing multiple letters, so it's kind of doing what we want. So let's print place. Let's replace all the B's with Q's, right? Just to see what happens. All right, looks like it worked. Nice. There's also a string replace method, but technically, well, I guess maybe we can allow it once we move past all the string methods. I guess after homework 4 we can probably allow it, unless of course I require you to make a string replace function. Then we can ban it. So let's see if this works. So let's say let's see if we can have. I think isn't there a replace function inside of string? Yeah. Then print it. Yep. So there is actually a string replace function, but the point is not that we're making anything that's like novel here, right? The goal is not to make anything that's going to shatter, be earth shattering. The goal here is to like look at a function to be like, oh, okay, I need the string, I need the find letter, I need to replace with, and then what I need to do is create a little local variable here, go through the string, do whatever I need to do, and then return it. So the code itself is not supposed to be the hard part, right? That's the idea here. Okay, so I also have a different idea for replace. We'll call it other replace. And it'll use other string methods, so I think it's a good... So, let's see. Why do you not like this? Shadow's name from outer scope. Let's see. Please. There we go. So, here's what we're going to do. What we're going to do is we are going to essentially convert this string into a list of characters. And the reason why I want to do that is because, let's say list of characters equals list of a string. So remember that that's what list does. So if you do list on a string, it converts it to a list of characters. Okay? And also, so what we also want to do here is, now that we have a list of characters, so why do we want to do that? Because what we want to do, and this is something that you might see in other programming languages more commonly, or actually even in Python it might be a vastly better solution than what we did before, was we would go through, say for I in range len, list of characters, which is also the same thing as, this is also the same as list of strings, right? And so, what are we going to do? What we're going to do is we're going to say, well, if the list of characters at I is equal to the find thingy, right, the find character, we're going to replace it. We're actually going to be able to replace it. So remember, you can't actually do this with a string, right? Because if you did this with a string, strings are immutable, right? But you can do this on a list, right? A list of characters. I can't type. There we go. Perfect. So we can do this on a list of characters. So that's why we had to do the conversion, right? But the cool thing about this is notice that unlike in the previous code, so let's just look at both of them together. So unlike in the previous code, we don't have an else, and the reason why is because if this if statement doesn't hold, then we just don't do anything. If you replace the character, you replace the character. But if you don't need to replace the character, you don't need to do anything. Here, we actually needed to do something because we needed to append this to a new string, right? This new string starts off as empty. So now what we can do is just return. And now here what we're going to get to do is do empty string dot join list of characters, right? Like this. And so what we see here is that we have now joined all the characters together, and we will return something. So let's test out this other one. So let's print replace other replace maybe. I don't know. What's a good word? Are there scripts from a place? Okay, doesn't really matter. And then let's replace all the S's with something else. Let's replace the S's with Q's. I don't know, right? It doesn't really matter. So let's just hit go and see what happens. So when we do that, we get some nonsense, right? The point is not that it's going to make any sense. I don't think the original set of words made any sense. But the idea here is that you see that all the S's are replaced with Q's, right? So at least it did work. So you see sometimes there's two ways to do a thing. Like here, we see two examples of a kind of, of a way to kind of attack what should we say? Yeah, of a way to attack the same problem in two different ways. I think generally this is a better solution most of the time, I would say. But Yeah, I mean, this whole lecture is going to be a live stream and it's going to be posted, yes. So, well, I mean, I'm not actually going to post it. What happens is that the live stream just becomes a video. So as soon as the live stream ends, it takes a little bit for processing and then it becomes a video. Okay. So let's do something else. All right. Let's do something else. So here's another string method that we can write. So let's write redo split, right? So instead of doing string split, so let's give it, you know, a string, something like this. And let's write a method that splits. So what does split do, right? Normally you do a string.split, right? But in this case, we need to do split on a string. And we're only going to split on all kinds of white space. So we have a bunch of questions to ask ourselves, right? And so why don't we write a little documentation. So what this is going to do is split on white space. Return. And so when you ask the question, what does it return? It's going to return a list of strings split by their white space. And when I say a string, this is the input string that will be split. So that's what happens. Okay, so cool. Now you might ask yourself, what is all this stuff here, or what is this here? So the idea here is that this is generally what PyCharm will generate in terms of documentation for a function. So this is like documentation of a function. And during your projects, we're actually going to require you to document your functions. The reason is because, and you'll see this, I think, once you've programmed for more than a few months, is that you're going to go back to your old code and you're going to ask yourself, what did the old code mean? And you're not really going to know. So basically, it's always good to write down what you're doing. And also, the other reason why documentation is good is especially because when another programmer, another programmer comes around and has to read your code, they know what your code is supposed to do, right? So maybe your code even has a bug in it or something, and so if they read your documentation, they're like, I can go in and fix that and make the code do what it's supposed to do. So let's write split. So how do we write split? So here's what we do. We will make a new list. So let's call this split list or something. It's empty list. And then what we're going to do is this. So I think it's a little bit difficult. Maybe I'm actually going to use a while loop, or I don't know, a for loop, something like that. So let's try to use a for loop. So for I in range len a string, right? And you could use a while loop for this, and it would be completely fine. I'm choosing to use a for loop for I'm not sure what reason, just to see what happens when we use a for loop for this, right? So when we use the for loop, what are we going to do? We're going to say if the character is white space. So basically, we need a little flag variable. So remember what a flag variable is. It's a Boolean variable. So I'm going to call this flag variable inward, and I'm going to start it as false. And so basically what this means is I want you to think about when we're splitting, right? So when we're splitting a string, if you have like, you know, a great many things, and we split this string. So the point is that when you attack this string, you're going to say, the first letter is not white space, so I'm in a word now, but then the next letter is non-white space. So that, or I'm sorry, the next letter is white space. So what I want to do is I want to end the current word, right? Oh yeah, she is. It did distract me. She's mostly a good dog. So yeah, a great many things, right? So and then here, once we get past this white space, and so what if we have like a bunch of white space stuff here? So we want to wait until we get to the next non-white space, and then we want to set in word to be true again. And then when we get to this white space, we want to set in word to be false again, over and over. Yeah, come here, dog. Come here. Come here. It's a little... Come on up. Come on. Come on. There you go. There she is. So, yeah, this is the dog. I'd bring her to class, but she's terrible. She would not be well behaved. Yeah. So, okay, back to split. So, what if we find, so if we're in a word, and a string at I is in the white space, and I'll make a white space list, right? Let's make a white space list. So what are all the things that can be white space? Well, space, tab, new line, carriage return. Those are the white space characters. So if we're in a word and the thing at that position is white space, then what we want to do is we want to say, okay, now we're not in a word. And actually, I think we also need a new variable. We need to remember the word start, right? Let's say word start equals -1, just for now. Okay, so what we're going to do here is we're going to say, we are going to split list dot append, and then here's something we have to think about. So what we're going to do, remember that string I is white space. So given that string I is white space, I guess she's still rambling around, huh? Yeah, so, what was I even thinking about? So a string is white space, so we actually want to slice the thing. We want to say a string from the word start up to I. Because remember that a slice does not include the last character, so it won't include the white space. So that's what we want. And then else, right? Yeah, maybe she is. She's very confused. Let's see here. Elif. Well, so if we're in word and a string is not in white space, and of course I'm gonna make this thing. So we actually don't need to code this one, because if we're in a word and the thing is not white space, then we just keep going, right? We don't stop. We don't do anything. So this is a do nothing, right? But it is an option, so we don't actually need it, but it's an option. If we're not in a word, right? And a string of I is not in white space, right? Those are the white space. So we can get rid of this one, right? And then what we do here is we say, okay, if we're not in a word and the a string of I is not in white space, then what we do is word start is equal to I, and then what we do is in word. Okay? And so that's what we do. So technically what you could do is you could also make a new word. So this is using slices. So it's a bit of a trickery, but that's okay. Remember that the point of this is to kind of get more comfortable with functions. It's not 100% to always feel 100% comfortable with whatever the function is doing necessarily. So, but I mean, this is a function that we could ask you as like a homework problem. It's definitely within the realm of possibility, especially given now that I've written something like this for you. So we could have you do something where, So let's try to split. Let's test it, right? So it's like what Professor Johnson always says, is that untested code, Prof J. He always says untested code is broken code, and I tend to disagree just a little bit. Basically, the only thing I would add is just potentially, right? That's my addition. right? So I agree mostly with him. I think untested code is usually pretty broken, but not always. So let's, a great many things, right? Let's see what split does on this, right? So we want to run our test and see if it explodes. And it actually, so it didn't break, right? I shouldn't say that. It didn't crash, right? So what's the lesson here? It didn't crash, so that's good. But the other lesson is it didn't work either. What it did do was it split the A, great, and many, but we gotta think. So I know I don't always use this term a whole bunch in class, but it's a term that's gaining a little bit more popularity. People say this a lot. What is an edge case? So an edge case is the idea of a case that only may run once per function or a few times, but has some exception in it, right? So if something's kind of exceptional, if it's a case that's not the main case, not always running. So I would say that the main case in this problem is where you have a word that's in the middle of a string, right? The end word is set correctly, all of that. And one of the edge cases is the first word. So I was a little bit worried if I was going to capture the first word, but I did capture the first word, so I'm proud of myself, right? Proud of me. I got the first word. But I didn't get the last word. So what could cause that problem, right? So what causes that to happen? And the answer is, let's go up and look at the code and think about it just a little bit, right? What causes us to miss the last word? So notice here, right? What has to happen, right? Every time we're in a word and the thing is white space, we add a word, right? That's what happens. If we're in a word and we encounter white space, then we add the word and reset the in-word variable, right? Which is good. But what happens when the string just ends, right? We're in a word, but the string just ends. So we get out of the... What actually is going to happen is we're going to leave this for loop, right? So actually what we need to do here is we need to check if we're still in a word after we already left after we left this for loop, right? If we're already in a word and we haven't added it yet, then we have to add it. So we have to go split list, dot append, what do we have to append? A string, and then we're going to do word start to the end of the string. So I guess the way to do this would be to length of a string. That's one way to do it. Remember, if you leave this off, it will just take the whole rest of the string anyway. Like, you can leave this blank. So I'll put that in a comment. Hang on. This is also acceptable. And we don't really have to set the in-word to false or anything, or reset word start or anything. The reason why we don't have to do those things is mainly because we're about to return. So the in-word variable is about to be deleted. The word start's about to go away. The only thing that's going to be left is the split list. The name split list is going to die, but the list itself will be returned, right? So, so basically, this is what we would call an edge case. And basically, the idea here is that it deals with the last word that may not have white space. So even without this piece of code, let me comment this code out, and then let me show you that that's what it was. So if I put a piece of white space here, and I rerun this code, you notice that it actually works now, right? If I just put a space on the end, then it works. If I take the space off, then it doesn't work anymore, right? Or if I put like some tabs in here, let's put some extra white space and just test, right? So that still doesn't work, but if I put a tab here, it works again, right? So the point is that our previous code worked, sort of. If you put a piece of white space at the very end of the string, then it'll fix it. And of course, maybe if you couldn't think of how to do this edge case stuff, what you could always do, which I don't suggest, is just be like, oh, I know what to do. I will make a string plus equals a space, right? You just add a space to the end of the string, like concatenate on a space, and then everything will work fine. But you shouldn't have to do that. That's a very dangerous type fix. That fix should always make you nervous. You're like, I'm basically like changing the input to avoid a specific bug rather than fixing the bug. Like, you should always try to fix the bug rather than fixing the input to avoid the bug. Though, you know, it's up to you, I guess. So this is an example. This is basically what the split function in Python is kind of doing anyway, right? So this is sort of, when you call string.split, this is sort of what it's doing, but it's doing it for you, which is nice. They pre-wrote this function for you. But actually, in a way, this function is something that you should definitely be able to write yourself, like in this class. So it's not something that's impossible. It's just something that they don't want programmers writing this function for themselves over and over and over and over again. So they provide it. That's the idea, right? So, okay. What are some other examples of functions? So we've done a check Pythagorean, we've done a replace, we've done another replace, we've done a split. What's another good example of a function? So I know that this isn't exactly how the homework problem works for Blackjack, but let's do a Blackjack example. I like the game of Blackjack. I've never actually played it for real money so far as I remember, but I like the game because it gives you good mathematical problems, or maybe even I like it. It's good math problems and good computer science problems come out of it. So it's a good game. So let's see if we can write some stuff. So basically, right, so let's write a Blackjack hand function. So maybe we write something like this. So in real Blackjack, the thing is that I know that in our fake Blackjack for your homework problem, so you can't use this for your homework problem, otherwise it's not going to work. But in fake Blackjack, I just had you pick a number between 1 and 13. But actually, in real Blackjack, what is it? And basically, what should I say? There's the cards 2, 3, 4, 5, 6, 7, 8, 9. And then you have 10. 10, Jack, Queen, King. They're all worth 10, right? They're all equal to 10 points. And then Ace is either equal to 1 or 11. Okay? So that's how it works. So let's say that let's say that you're given a Blackjack hand. So this is a hand of Blackjack, meaning that it's this will be a list of, we'll say that the parameter hand is going to be a list of numbers, or Jack, Queen, right, King, and Ace. And then our goal is to give the value of that hand, right? And so let us try to do that. So here's how we are going to do it. What we're going to do is we're going to say for card in hand, right? If card, let's just say if card is in, say, Jack, Queen, King, right? We're gonna say value plus equals 10. And of course you're like, what is value? Value is a variable I'm about to declare. Right, so we'll start the value off at 0. So if the card is in Jack, Queen, or King, we'll add 10. If the card is equal to Ace, then actually there's a number of things we have to do. But let's just do a simple version of it. Let's say that if the value is less than 21, or actually no, if the value is less than 11, then we'll add 11. Else, we'll add 1. And so that'll avoid immediately busting, but I don't think it's going to be perfect, so this is not perfect, but it's just a good example of not perfect. Maybe I'll make you guys do a real version of this with recursion, or something like that. So I like that. It's a good problem. I think I've just written a problem. But this is not the problem. So the problem is almost this. But then else, what we're going to do is value plus equals card. So otherwise, it's just going to be a number. So now if the value is bigger than 21. So what if you get bigger than 21 in blackjack? So the answer is if the value is bigger than 21 in blackjack, you go, I think they call it bust, right? Which just means that you've gone beyond the allowed number, so you lose the hand. This is automatically lose. So we're going to set your value equal to, let's just set it to bust, right? Else, well, actually, maybe we don't need an else. Else we'll just return the value, right? Okay? All right. Cool. So let's do some of this stuff. Yeah, and technically, yeah, so blackjack is, what, ace and jack? Yeah. But unfortunately, this simple version, I don't think we're going to be able to... I guess we could. Well, is it jack and ace, or is it just a face card? Let's look that up, actually. I'm curious now which one it is. So, blackjack is ace and face. Or... okay. According to Googlepedia, the greatest source of the universe, any face card or even 10. So, at least that's what this says here. And I believe it because I read it on the internet. Right? It says you gotta get an ace, and you gotta get a 10, jack, queen, or king. And that's either any one of those is counted as blackjack. So, and you also have to have 21 and just have 2 cards. That's actually kind of complicated. So maybe we'll... Yeah, so maybe we'll write a different function that actually does that. That's a good question. So we'll do that. Yep, so let's return the value. And then we can even write something like... Let's write a function that says... Interesting. So you guys disagree with the internet then, right? What is the ace? Oh, no. Blackjack. Let's see. I don't know, this website also says that it's just a face card, or I don't know. Oh, now we have a disagreement, right? So what you guys would say is if jack, you know, in hand and ace in hand, is that from the movie 21? I think I've seen the movie 21, but so I know you can. So the thing is, you so this is what you would say. This is your guys' version of this function, right? But I think I'm gonna do the other version because it's the one I kind of know and believe in. I could be wrong. It doesn't really matter. So we're gonna say if, and we also need to check if the length of the hand is 2, right? We can't have multiple, so you can't have hit and got more cards. You have to just have an ace and a face. You can't have like 14 cards and still win. So the length of the hand has to be 2. And, well, and if the length is, let's say, else, return false. And then in here, what we're going to do is we're going to say, if hand of 0 is equal to, say, ace. So this is not a very smart way to do it. Then what we're going to do is we're going to say if hand of 1 is equal to, or is in 10 Jack. Queen King, right? Then we can return true. Yeah, I don't know. I hadn't heard that before, but of course, like, I'm sure that there's somewhere where they're like, oh, well, you know, the true blackjack players wouldn't call a 10 and an ace blackjack. I'm sure there's somewhere that someone says that, I'm sure, but, and then, of course, this, right? So there's I mean, I feel like this is kind of a bad way to do this, uh, but it kind of works. I guess, really, yeah. I mean, I get, you know, the other way that I'm thinking to do it is basically to say if ace is in hand, then we do is a for loop. We say for, you know, card in 10 Jack Queen King, right? So this is one idea, which I don't particularly like it. The reason why I don't like this idea, so let me tell you why I don't like this idea. It's not that bad. It works. The reason why I don't like it is just because we're accessing indices too explicitly. Feels very dangerous. But, you know, if this is a solution that you come up with in one of your projects, absolutely you could, right? Well, so you can't, yeah, you'd have to be like, right, and 10 in hand, or Jack in hand, or Queen in hand, or King. Now, of course, you might say something like, ugh, that is ugly, and I agree. So I agree, and there's actually a way to fix that in Python, is to use the any keyword, but I don't usually teach the any keyword. So this will tell us if there's blackjack. So let's test some stuff out, right? There is, yeah, there is. It's the any keyword. What you can add, so this is something that we usually have banned in the class, and I will continue to have it banned. So here's the banned version. Basically, if ace in hand and x in hand for x in this, and you just put an n here, which actually doesn't really change the length of code very much. So why doesn't it? Okay. So this is the banned version. There's the only reason why I ban this is just because we don't teach it, and because I don't want people to spend their time trying to figure out what's going on with this thing. Like, it's complicated actually what's happening here. So I don't want people to worry about it. So we just ban it to say don't do it. So let's test it out. So let's give it a hand. So the hand, let's say an ace and a 9. So this should be a non-blackjack, right? So this should be a false, right? So that should be false. Let's try ace and jack, or okay, I can take the king. Let's also try ace and jack, and ace and queen. Let's test them all out, right? Ace and 10, or maybe we'll do 10 and ace this one, because remember that in for those of you who've ever played, it doesn't matter which order the cards are, right? You can have an ace and a queen, you can have a queen and an ace. They're both the same, right? You're allowed to shuffle your 2 cards in your hand. Let's try it with multiple cards. Let's say that we have a 3, an ace, and a 10. So say you got a 3 and an ace, and you're like, ah, crap, I only have 14, I'm gonna lose. So then you hit, and you got a 10. Hopefully this returns false. Good, right? The reason why we want this to return false is because technically this is, once you have 3 cards, then you can't have a blackjack, right? Because it has to be an ace and a face or an ace and a 10. That's it. So it can't be 3 cards. It can't be like, 2, 3, 2, 5, ace, right? And this all adds up to 21, I guess, if the ace counts as 1, but it's not a blackjack. Oh, good. Cool. I think that's enough blackjack for now, but I do like the game at least. I like the problems that it creates. I like the thinking that you have to do. I think that this is a good little bit of code that you should read through and understand. So remember that you can't actually just do 10 in, like 10 or jack or queen or king in. Because remember that in is a comparison, right? And so in has a higher precedence than and or. And so what's going to happen is the in gets evaluated first. So this 10 in hand, jack in hand, queen in hand, king in hand, they all get evaluated first, and then the ors get evaluated. So the ors get evaluated second, which means that by the time that these things get evaluated, it's just true, false, true, true, or false, true, false, false, or whatever, right? So that's what ends up getting evaluated. So it's like false or true, or false or false, or true or false or false, something like that. So if all of, so the problem is that that's why we can't do that's why and it doesn't distribute, or the in doesn't distribute over the or, right? It doesn't work like that, sadly. Okay. Unfortunately not really, because, I mean, like, you would like to be able to say, like, what your goal would be is, like, 10 in, right? Like, you would want to say something like 10 or jack or queen or king in hand, like this, right? But the problem with doing a parenthesization like this is that it's actually, the ors are going to, because of the parentheses, it's going to evaluate these, even though these have the lowest priority of anything, these have the lowest precedence, they're actually going to evaluate first because they're inside the parentheses. So it's going to be, a number which is not 0, so true, a jack, which is a string, really, right? So it's like a string, so that's going to be true, right? It's a non-empty string, non-empty string, non-empty string. So it's going to be, is true in hand, and that's actually going to be a problem as well. So there, as I say, the actual way to do it is probably to use this any keyword, but there's a reason that it's banned. So I think that this is probably the best code that you can write for at least this particular example. I think this, and you know what, sometimes you just have to come to terms with the fact that, like, always, so as much as I focus on the beauty of your code and how good it looks and whether or not it's the optimal code to write, remember that working code is better than beautiful code, right? Beautiful code that doesn't work is garbage. Working code that's a little ugly is totally fine, right? As long as it works. Like, maybe there's a better way to do this, but if it works, that's the primary question. You don't want to, write code that doesn't work just to make it prettier. Okay. So let's think of another function to write. Let's make this our last example for today. So I did this example in the previous class, and I think they hated it, so I'm going to do it now. So I'm going to do rotate 1, right? And I think this is a lab, or I forget. This might be a lab coming up. Well, maybe I shouldn't do it if it's a lab. I think I kind of... Yeah. So what's another... what's another type of function that you can make? Oh, here's a funny way to calculate pi. So this is probably the dumbest way to calculate pi in the history of the universe, but we're going to do it this way. So here's a way to calculate it. What you want to do is you want to basically pretend that you draw a circle, right? So let me just let me show you what I mean by this. So let me write something out. This is something that I just thought of. Well, I didn't just think of this. I promise you I did not just think of this. But I'm stealing this from something. Oops. So I also want a circle of the same radius, but I don't know exactly how to trick it to do that. So let's put a circle in this square, and then let's shrink the circle down until it's about right. There we go. So let's say that we shoot arrows at this circle, right? And let's say that we're guaranteed to get it into this square, right? Then what's the probability, right? What's the probability of hitting circle, right? And so let's say that the side length here, let's say that it's a radius 1 circle. So let's say that the circle is a radius 1, right? The circle is radius 1. So this square has side length 2 and 2 over here, right? So it's a square of side 2, and the circle is a radius 1 and all that stuff. So for a radius 1 circle, what is the area of this total square, right? The area of the square is equal to 4 of the square. The area of the circle is going to be equal to pi times the radius squared. So that's equal to 3.14. But wait, that's cheating. We can't do that, right? So all we know is that it's equal to pi, right? And so what we can say is that the probability, right, the probability of hitting the circle is, well, the area of the circle, pi, divided by 4, which is the area of the square. So if we want to calculate pi, what we can do, and let me just import random. Right? Let's import random. And so what we're going to do is we're going to generate a random value. And then we're going to shoot arrows at the circle. And in the end, we're going to calculate pi by random number. So this is going to be the number of arrows that we're going to shoot. Okay? And then how do we know if we hit the circle or not? The only way we know if we hit the circle, we're going to generate x is equal to random.random. And let's see, y is equal to random.random. And so then what we're going to do is we're going to say, actually, the trick is that when we generate random, it's actually going to be numbers between 0 and 1. So actually, it's only going to hit this upper quadrant here. So the area of this thing is actually 1 and 1. And the area of the circle is, what? 1, I guess it's pi divided by 4. So actually, the probability of hitting the circle is still the same. So that's nice. So what we want to do is we want to find this probability. So we want to calculate the probability equals 0. Or at least let's count the number of hits, right? Equals 0. And then what we're going to do is we're going to say if x squared plus y squared is less than or equal to 1. So if we're inside the circle, we're going to increment num hits. Right? So we're going to increment num hits. All right, so what we're going to do is for I in range num arrows, right? Just a little for loop, no problem. And so if x squared plus y squared, we need to move this inside the loop, otherwise that's a problem. Otherwise it's going to be the same number every time. So if the number of hits is that, then we're good. So we're actually calculating pi over 4. So what we're going to do here is we're going to divide, we're going to say num hits divided by num arrows, right? And that calculates pi over 4. And so we're going to multiply this by 4, and that's what we're going to return. So return 4 times number of hits divided by number of arrows. Remember that this is floating point division, so it's going to cast everything into a float. So that's going to give us an approximation of pi. All right, so let's run this thing and see what happens, right? I'm excited to see if this works or if it just breaks. So let's print out, let's say while, let's see, count is not equal to 0. And of course I need count equals int input. What is the arrow count? And then we'll put this in the loop too. and then we will print out calculate pi on that number of arrows. So, okay. So, what are we gonna do? So let's run this thing. So what's the arrow count? Let's try 5 arrows. See what happens. So that says that pi is 2.4. Let's try 10 arrows. 3.6. Oh, that's pretty good. Let's try 10 arrows again. 2.8. So you see that it's kind of changing a lot. Let's try 50 arrows. 3.12. Interesting. All right, let's try 50 arrows again. 3.68. Ugh, not as good. 3.6, not as good. 3.2, that's a little better. Right, we're looking for numbers like 3.14. So 3.36, not as good. Let's try 250 arrows, right? 3.168. So that's getting closer. Let's try 250 again. Ooh, same number. 3.008. That's a little low. 3.088. 3.056. 3.168 again, right? Let's try 2,500 arrows. Let's try that. Interesting. So after 2,500 arrows, our approximations are slightly better, right? Shooting 2,500 arrows. Well, let's try 25,000, or let's try 100,000 arrows. Ah, nice. 3.14. We finally got 3.14. So we see that it's not getting the same number every time because it's random, right? It's actually generating random arrows and shooting it at the circle. Now that was only 10,000, right? So it's giving us new numbers every time, which is pretty cool. Let's try 1 million arrows, right? 3.142. Unfortunate. Crap. We wanted a million. Let's try a million arrows again. 3.14 again. That's nice. Getting 3.14. So it takes about a million arrows, right? 3.141. Oh, that was nice. That was actually correct. 3.141. See, that was correct again. So after shooting a million arrows, we're getting approximately pi, right? We're getting approximately pi. 3.14. So I think in order to shoot, like, let's see what happens when we do 10 million arrows. We have to wait a little bit. Hopefully it doesn't disappoint. It did. See, of course 10 million arrows would disappoint a little bit. Ah, 3.141 again. So it's not all that much better actually than the, let's try 100 million arrows. Well, no, 10 million arrows again. One last time. Nah. Okay, cool. So, is this a good way to approximate pi? Right? But it's amusing, at least, right? I mean, yeah. I'm not saying it's smart. I'm just saying it's just a little trick. So anyway, okay. So then the last thing I want to remind you guys before I go, because I have to go and pick up my tire, and they close at 6 and blah blah blah, excuse. So I'll probably end class like 5 minutes early a little bit, but I'll go for about another 5 minutes. I did want to remind everybody about not just about scope, but I want to remind you about mutability, right? It's my favorite thing. We always want to talk about mutability. Remember, if you pass, so let's say that we have some function that says something like, that's a good question actually. Which one should we talk about? Let's just make a new function, right? Let's say modify string. And it takes a string, right? And so what we're going to do with the string is we're going to, so here's the trick, right? Can the function actually modify the string? The answer is not really, because strings are immutable. So But what if we do something like a string is equal to hello, right? So regardless of what the string is, we're going to set it to hello, right? And so what we're going to do here is we're going to say my string is equal to definitely not hello, right? And then what we're going to do is call modify string on my string, right? And then we're going to print it out. So this is something that I want you to basically understand. Like, I don't know if it's intuitively or just have it kind of memorized. Just think about this, right? So we have a my string, definitely not hello. We modify the string, which all the function does, right? And I'm going to do this, even though don't do this, right? Don't put functions, or actually we'll do this. So yeah, so don't put your functions under your if name, put them on top, but I'm just doing this for educational purposes or whatever. So the first thing we do is the arrow count, 100,000, or 10,000, whatever, 10 million. So the point here is that what we're going to do when we, so the point is here that the string is not modified, right? The string is not modified. And the reason is because it is immutable, right? According to Python, strings are immutable. But if you have a list, right? So say my list equals, what? Hello, goodbye, Mountain Dew. Right? And we say modify list. And we're going to say a list, and we will say a list dot move, right? We're going to remove hello, and we are going to append a list dot append robot, right? And I guess maybe we should check to see if hello is in the list. So if hello is in a list, just to do it for safety, even though of course we know that it's in there because we just have it, but just safety, modify list, a list, and then we can print a list, right? And so, I'm sorry, my list. So the point is that if it's immutable, if it's an int, right, just like int, float, bool, and string, right? So those things are immutable. Now, for mutable things like lists, this will actually modify. So let's set the arrow count to 0, and you see that hello has disappeared from the list, and robot has been appended. And you see the problem with that, or I don't know if it's a problem, it's a feature of the language, right? It says that if you're going to pass a list into a function, that list is passed by reference, right? So lists and dictionaries, which we'll talk about after, later, are passed by reference, not by value. And so we would call this being passed by value. It's an old kind of expression, which basically means a copy is made, right? And so you remember my drawings with the arrow business, right? About how lists have two different arrows that are pointing in. This is the same thing, right? There's two arrows pointing to this list right now, right? There's my list, and then there's also the a list local variable that both have arrows that point to the same actual underlying list. So that's what happens here. Okay. Yeah, I like talking about mutability. I think these two examples are basically, if you can kind of, I don't know if I'd say memorize. What I would say is go over these examples and just kind of know them, understand them, be like, I understand the difference between these two things, even though, of course, these are the, same, and really these functions are pretty basic. So try to understand the distinction between the two. And if you can understand the distinction, then basically you should be good to go with mutability, right? Like, all examples of mutability will come back to something like this, where either a copy is made or the list is passed as a reference. Yes, exactly. Mutable is mutatable. Yes, it's kind of a, what would you call it? It's a mushing together of the two things. All right. I think that's it for today, because I have things to do that do not relate to lists and mutability, sadly. I am sorry that I did not come in person today. I promise you that class. This is only an exception for when truly bizarre things happen. Like if I catch COVID or something and I can't come into campus, then I'll do this. But generally, lectures will be in person. Next lecture, next week, in person. So, yeah, unfortunately, the number of tires on a car has to be greater than or equal to 4. And currently, my tires 3, which is insufficient. So, I will go and remedy that problem, and then I will see you again next week. All right. Have a good rest of your week, and yeah. All right. Time for the outro.